All right, so we're gonna go ahead and do conservation of charge. And this one sounds harder than it is. Conservation of charge is just going to talk about how if we have a positive 3 microcoulombs over here and we have a negative 1 microcoulomb here. And then what we would do is we would take them, oh, hold on, I forgot I have to do the boxed version of this. And we would move it, touch them, and then put them back where they were. Go away. We would get an average of the two charges. We have to have the same amount of charge that we started with. We have 3 microcoulombs and negative 1 microcoulombs. The total amount of coulombs is 2 coulombs. So each one would evenly distribute this as 1 microcoulomb. All right. So all you would have to do in this situation is take the average of the two things. And then we just have to have the same amount of charge that we started with. We can't just completely lose charge. All right. Polarization just states that if you bring a charged rod like this negative rod I have near, what's going to happen is if this is a negatively charged rod, I'm going to zoom in, a negatively charged rod, what will happen is the positive charges will come near this side and the negative charges will move away from there and go over to the other side. And inside it would polarize. Now, I have noticed they've asked a follow-up question 1 or 2 times, and since this is a review, we can be free to talk about this. There would be an electric field induced inside of this. So we would have our electric field lines would go from here to here. Okay, moving right along. And this is brought to, but not touching. If we were touching, 2 different things could happen, right? We have conductors and we have, we have conductors and we have insulators. In conductors, charge moves freely. An example are most metals. And then insulators only become locally charged. So kind of charged like where we touched it. Rubber is an example of this. So when I touch a rod that is negatively charged to a metal, that negative charge moves on to this sphere and moves away from each other. So it evenly distributes throughout. And on this one here, if we touch it there, it's only going to charge a little tiny spot right there. And it's actually kind of hard to even charge rubber like that. But let's talk about the different ways that you can. So there are 3 ways to charge. Conduction is one. And this is just where we touch them together, like so. Okay. Induction is much more difficult. You have to charge it without touching it. So how we would start out, I'm trying to zoom in, there we go, is you would put a negatively charged rod near 2 touching uncharged spheres.
Hi, Mommy.
Walk away. So you would have your positive, all the positive charges will come over into the right side, the left side, and all the negative charges would go into the right side. Once that happens, what you're going to do is you're going to keep the charged rod near, but then you are going to separate this. So kind of if we were going to do a little look at this, while that is here, we are going to move it away. And then you can then remove this rod and they will stay as a positively charged sphere and a negatively charged sphere. Oops, I didn't mean to paste that. Okay. The last way is to charge by friction, which is really usually how we would charge rubber. And when you rub it, there is a transfer of electrons either to or from the object that you would be rubbing. And it depends on what we rub with that we would gain or lose electrons. So to figure that out, they would probably tell you if you needed to know, but the other way you would look is the triboelectric series. And that tells you about how electron affinity, which is just how bonded the electrons are and how easily they can be removed. Okay, moving right along. I'm going to stop this video and do the next one.